In 5.4, we talked about sum and difference formulas, which are a series of trigonometric identities which allow us to evaluate, verify, and solve certain trig problems using these formulas that break down an angle into the sum or difference of two other angles. And this allows us to evaluate angles that we previously couldn't really evaluate without use of a calculator. Something like what we saw in our example of cosine of 75 degrees. We were able to think of this problem as the cosine of 30 plus 45 degrees, and using the sum formula, actually evaluate that and be able to get a value. So I want to continue on and work through just a couple of problems that we weren't able to get through in class. Some of the types of things that you might see and uses for sum and difference formulas. So let's just go through a couple of these. First off, we have an expression here that looks kind of complicated at first, but if you look at it carefully, you see that it's really just following the structure of cosine A, cosine B, plus sine A, sine B, where we're treating this as our angle A and this as our angle B. So this is our A and this is our B. And if you look at that carefully, you'd ask yourself, all right, which of the sum and difference formulas is this? And this is just simply cosine of A minus B. So if we want to go ahead and rewrite this, if we know that this is just simply cosine of A minus B, oops, I should probably put parentheses around that, then we write this as cosine of 4 pi over 9, which is our A, minus pi over 8, which is our B. And what we just need to do is just subtract those two fractions now. So we're going to need a common denominator. So that would be 72, which means we're going to multiply our numerator here by 8. So we get 32 pi. And this one here by 9. So that's going to be 9 pi. And this is just going to allow us to rewrite this as 23 pi over 72. Okay. Let's make that a little bit smaller so it doesn't bleed into the next problem. All right. This next one is a pretty common problem that we will see. We're looking at this one here. Cosine of u, we're told, is negative 15 over 7. And they are stating that u is an angle between pi and 3 pi over 2. So what that means is this angle u is in quadrant 3. We know it has to be in quadrant 3. We're also told that the sine of some angle v is equal to 4 over 5. And this angle v is between 0 and pi over 2. Which means we can state that it's in quadrant 1. So the problem is giving us two different trig function ratios, and they're asking us to find the value of cosine of u minus v. So what we're going to say is cosine of u minus v, using our difference formula, is equivalent to cosine of u, cosine of v, plus the sine of u, sine of v. Well, let's start filling in what we know. We know that the cosine of u is given to us, and that's negative 15 over 17. What we don't know is what the cosine of v is. We know what the sine of v is, but we don't know what the cosine of v is. Well, given the information, actually, we can figure out quite a bit. We know that angle v, and let me just do this in a different color. Angle v here, which would be this, we know that the sine of angle v is 4 over 5. Meaning if we were to drop a vertical down here at angle V, our opposite is 4, our hypotenuse is 5, and right away, using Pythagorean triples, we can identify that this angle here must have been, or this adjacent side, I should say, should have been 3, or should be 3. It's a 3, 4, 5 triangle, because we dropped a vertical. And so since we know it's a 3, 4, 5 triangle, we can then say the cosine of angle V would be 3 over 5. Okay, and we're going to employ a similar process here for this next part. We know the sine, we don't know the sine of u. We know the sine of v that was given to us. That's 4 over 5, but kind of the same deal. We need to figure out what the sine of angle u is, and let's just do that in a different color. Sine of u. Well, what do we know about the angle u? We know it's in quadrant 3, so I'm just going to draw this kind of random line here. We know it's in quadrant 3, and we know that just because I'm going to be kind of bothered by this, we know that our adjacent side for our angle u, right, this angle u, our adjacent side is negative 15. Our hypotenuse is 17 because we know cosine of u is negative 15 over 17. And again, this is actually another Pythagorean triple. But if you can't figure that out, you could always just use the Pythagorean theorem. But this would come out to be -8. We know it's negative because our opposite side is below the x-axis. So we can then say that the sine of this angle u would be -8/17. So that's how we can use what we know from these trig functions and these angles and their placements to actually plug in the values for all of these trig functions. From here, it's just basic arithmetic. We've got, this would be -45/85 plus -32/85. And so this would be our value. Okay. All right. So we're going to do some pretty similar problems to that just down below. So I would encourage you to pause the video if you haven't already done so and try these problems on your own. But I will go ahead and upload our solutions to this in Google Classroom. But hopefully that helped with the previous two examples of how to evaluate and rewrite using those sum and difference formulas.